Hi everyone. In today's video, I'm going to discuss periodicity and extremum of trigonometric function, that is extreme values. First, I will discuss the official and as per the textbook, what is the definition of periodicity and period of a function, a trigonometric function. So let's discuss. Let's see the definition. A real function f is a to r is said to be periodic if there exists a positive real number t such that f of x plus t is equal to f of x for all x belongs to a, then the least value of t is called period of f of x. So what is meant by least value of p here? Let's see the example. So what is the period? What they are telling is, if I'll assume any function f of x is equal to sin x is one function. See, f of x plus t, in the sense this place t I'll replace with pi by 2. So because it should be only positive real numbers. So f of x plus pi by 2 means that is a sine of pi by 2 plus x, which is cos x. So which is not equal to our f of x, means it's not equal to sin x. So this is not the period. So pi by 2 is not our period because we are not got f of x plus t as the f of x. Let's find out f of x plus pi. So that is sine of pi plus x. So which will get minus cos x. This is minus sin x. This is not at all our f of x. Next, f of x plus 3 pi by 2, like this, sine of 3 pi by 2 plus x. This is in the fourth quadrant. So sine is negative and it will be minus cos x. So this is also not f of x. So when I'll replace this with 2 pi, so f of x plus 2 pi, we can write sine of 2 pi plus x, which is equal to plus sin x, because this is in first quadrant. So we got the f of x. So this is the least value of t where the function f of x plus t becomes f of x again. So therefore we can say 2 pi is the period of f of x is equal to sin x. So this is the way. So how can we decide from the definition of periodicity? So same thing we can discuss by using the graph also. So by graph, how to discuss the period of sin x. So let's just see, first of all, I'll assume y is equal to sin x is our function. So for this function, first I will take different x values I will take. So for the different x values, so I'll find out the y values. So by that we can discuss the graph of this one. So y is equal to sin x. First basically I'll take 0 only. So sin 0 is 0, and then I'll take pi by 2. Sin pi by 2 is 1, and sin pi is 0. Sin 3 pi by 2 means 270 degrees is minus 1, and sin 2 pi is 0, and sin minus pi by 2 is minus 1. Sin minus pi is 0, and sin minus 3 pi by 2 is 1, and sin minus 2 pi is 0. So what we got the coordinates, order pairs here as 0, 0, pi by 2, 1, pi, 0, 3 pi by 2, minus 1, 2 pi, 0, and minus pi by 2 comma 0, negative 1 on negative x-axis, minus pi comma 0, and minus 3 pi by 2 comma 0, and minus 2 pi comma 0, minus 2 pi comma 0. So let's we draw the graph for this one. So let's we take x-axis and y-axis. So this is y-axis, let us assume, and this is the x-axis. This is the x-axis. So let's see how to draw the graph. This is x o x dash and y o y dash. So on x-axis, what I took is each 90 degrees, like 0 to pi by 2, next pi, and 3 pi by 2, and 2 pi, so and so on. Comes to the negative x-axis, I'll get minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So if I'll take on y-axis 1 and 2 and so on, this side is minus 1 and minus 2. So let's put the points. Let's plot the points. So this is 0 comma 0, pi by 2 comma 1 means here it will be pi comma 0, 3 pi by 2 comma minus 1, 2 pi comma 0. And this side minus pi by 2 comma minus 1, minus pi comma 0, minus 3 pi by 2 comma 1 we got, and minus 2 pi. So this is a free-handed curve. By mistakenly also don't use a scale, and it is a smooth curve like this. It is a free-handed curve. It is a free-handed curve. So you get like this. So this is the graph of sin x. This is the graph of sin x. So if you observe carefully, sin x is taking all values of real numbers. So for every real number, it will give some output. So it's not like that, it is not defined somewhere. So it is defined for all the real numbers. But when we are observing the graph, the maximum value what we are getting is 1. And what we are getting, the minimum value is minus 1. So minimum value is minus 1 and maximum is 1. Means, so whatever you will substitute the real numbers in sin x function, the output will be only between minus 1 comma 1. So this output is called range of sin x. So that is minus 1 comma 1. That means we can write like sin x is always lies between minus 1 comma 1. Sin x is always lies between minus 1 comma 1. So this output is called range, and the values what it is taking is called domain of this function. So domain of the sin x is real numbers. So if you'll observe clearly in the graph, one more thing. So if I'm starting the graph at 0, so from here my graph is starting, and when it is coming like this and coming like this and coming like this, and when they started repeating the graph like this, so the length of the interval from where it is started and till where it ends, and again it started repeating. So this length we are seeing 2 pi length. So we are seeing the 2 pi length. So this is called the period and periodicity of the sin x. So graphically, how can we say the period of this sin x function is t is equal to 2 pi. So t is equal to 2 pi. So this is the graph of y is equal to sin x function, where x belongs to all the real numbers and the range is only minus 1 to 1. So this is the period of sin x function. For example, if I multiply this angle with any number like sin 2x, so what happens? What is the period of this sin 2x function? So if you'll observe carefully, so I'll take here values, tabular form for this sin 2x. So when I'll consider the values of x, so like this 0, pi by 4, and pi 3 pi by 4, pi by 2, and 3 pi by 4, and pi. So like this if I'll take, so what happens? Just we'll see here. When I'll put the 0, automatically y value you are getting the 0. Sin 2x is sin 0 is 0. So when I'll put the pi by 4, what you'll get y value is sine 2 into pi by 4. So means it is the sine pi by 2, which is 1. So when I'll put the pi by 2 here, sine 2 into pi by 2 means 2 cancel, sine pi is 0. Next you will get minus 1. Next you will get 0, like this. So when we will draw the graph for this one, so how we will get? So what are the order pairs we got first of all? So we got the order pairs as a 0, 0, pi by 4, 1, pi by 2, 0, and 3 pi by 4, minus 1, pi, 0. So like this we got the order pairs. So if you'll see graph for this one, let's see, this is y-axis, and this is x-axis. So let's see, take y, o, y dash, x, o, x dash. So here, what are the intervals I took here? This is 0 and pi by 4 and pi by 2 and 3 pi by 4 and pi. So even minus pi by 2, minus 3 pi by 4, minus pi. So if you look at the graph of this one, so 0, 0 is here, 0, 0 is here, and let's take 1 and 2 and minus 1 and minus 2. So pi by 4, 1 will be here, and pi by 2, 0, 3 pi by 4, minus 1, and pi. So it will be like this. The point, plotting the points will be here like this. So when you will draw the graph for this one, so it will come like this. So since it is a free-handed curve, we cannot use a scale. So if you'll observe clearly here, the graph of this one starting and ending within the period of pi. So it is ending within the period of pi. Length of the cycle is pi. So period of this one, so period of sine 2x, is becoming pi. So that means whatever the original period, t is equal to sine x, period of sine x is 2 pi. When this x is multiplying with the number 2, the period is dividing by that same 2. Means you are getting the pi. So what we understand from this? When a number is multiplying, to our function angle, so like sine ax, so its period will be divided with the same number. So that means if I'll take sine 3x, so its period will be 2 pi by 3. If I'll take sine x by 2, so its period will be 2 pi by 1 by 2. That means 4 pi is the period of sine x by 2. So this is the way how we will find out. So the general formula for period of sine ax is 2 pi by mod a. So similarly, period of cos ax, period of cos ax is equal to 2 pi by mod a only, and the period of tan ax is equal to pi by mod a. So like this we can find the period of trigonometric functions. And here one more thing is when two or more functions comes, like f1 of x is one function, f2 of x is another function, f3 of x is another function, f of 4 is another function, and they are connected like this with this relation f1 of x plus or minus f2 of x divided by f3 of x plus or minus f4 of x. So when we can see these kind of things, we have to find out period of each function individually, and we have to take LCM of period of this one is, let us assume P1, P2, P3, P4. So take the LCM of P1, P2, P3 and P4. So we will take this all whatever we will get, that is the period of period of the function what they are given, combination of all the terms, combination of all terms. So, and one more thing, one more important point here. So when we are multiplying or dividing with the angle, so it is accordingly the period of that one is either dividing or multiplying with the original period. But when something number is added or subtracted to the angle, like sine of x plus 3 or sine of x plus 5 by 2. So there will be no change. There will be no change in period of sine x plus. That is nothing but you will get 2 pi over here. So when the period is changes means when some number is multiplying to this variable or dividing to that variable, then only period will be changes. So please remember this point also. Next up, here we have few things like some standard functions. So we will discuss directly. I will write here and a few things like sine power nx, cosecant power nx, cos power nx. Okay, cos power nx we will write here cos power nx, secant power nx. So for this, what are the periods? So what are the periods is if n is even, so the period is pi. If n is odd, so period is 2 pi. So for tan power nx, for cot power nx, so if n is even or odd, so period will be pi only. And this is when you have the powers for the trigonometric functions. And next one, when you have the modulus like mod sin x, for mod cos x, mod tan x, mod cot x, mod secant x, mod cosecant x. For this all, period is common, that is pi. And for x minus box of x means this is a least integer function. So for this, period is 1. So let's see how mod sin x, period is pi. So if you'll observe clearly, the graph of sin x, what we are getting here, the graph of sin x will be like this. The graph of sin x will be just as shown like this here. So it will be like this, 0 to pi by 2 and pi 2 pi, like this it will be. So this is 0, at pi by 2 it will be 1, at pi it is 0, at 3 pi by 2 it is again minus 1, 2 pi is 0. But when I'll keep the mod for this one, when I'll keep the mod for sin x, there is no chance of getting the negative values. So this graph will be shifted to the positive sign only like this. So means every pi interval, the graph of mod sin x is repeat again. So that's why period of mod sin x is pi. So hope everyone understood. So let's see some problems. So how can we find this one? So let's see the problems on period and periodicity, and then we will go to the extreme values of trigonometric functions. So how to find the period of the functions? Let's see examples. Examples of period. So first example, what we have is find the period of find the period of um, find the period of cos 3x. Find the period of cos 3x. Let's see. So generally, what is the period of cos ax we discussed? That is a 2 pi by mod a. 2 pi by mod a. So in place of a we have cos 3x. That means so period will be 2 pi by 3. So this is the period of cos 3x. Period of cos 3x. So next example we will see. we'll see the next example. What is the next example is find the period of find the period of find the period of uh, tan tan x plus 2x plus 3x plus so on plus nx. So let's see the solution for this one. What they are given is tan of x plus 2x plus 3x plus so on plus nx. So from this, we can take x is common. We can take the x is common. So what we'll get is a tan of x into, you'll get 1 plus 2 plus 3 plus so on plus n. So what is this? This is sum of first n natural numbers. So what is the formula to find this one is n into n plus 1 by 2 into x. So this is the simplified form of that tan question what they are given. So what is the period of tan ax? Period of tan ax is pi by mod a. Pi by mod a. So here if you compare this with tan ax, our a value is n into n plus 1 by 2. So what will become the period of tan this one now? So period of tan n into n plus 1 by 2 of x is equal to pi by n into n plus 1 by 2. So that means 2 pi by n into n plus 1. 2 pi by n into n plus 1. This is the period of this function. So next, next, let's see one more different kind of question based on this. So that question is find the period of cos x into sin x minus 2 pi by 3. Cos x into sin x minus 2 pi by 3. So here three different trigonometric functions are multiplying. So that's why let us assume this is some f of x. F of x is equal to what they are given is cos x into sin x minus 2 pi by 3. Sin x minus 2 pi by 3. So if I will multiply and divide with 2, I'll get 1 by 2 into 2 cos x into sin x minus 2 pi by 3. So this is the 2 cos a sin b. So 2 cos a sin b formula what we know. So that is a sin a plus b minus sin a minus b So let's use this one. We'll get sin a plus b in the sense x plus x minus 2 pi by 3 minus sin x minus x plus 2 pi by 3. So this is what the according to formula. So 1 by 2 into sin 2x minus 2 pi by 3 minus x and x gets cancelled here, sin 2 pi by 3. So this is a constant value. So for this, we will not take period. So only for this function, we should take the period. So if you multiply this 1 by 2 inside, 1 by 2 sin 2x minus 2 pi by 3 minus sin 120 here, sin 120 is root 3 by 2. So it will become root 3 by 4. So I told you already, if any number is adding or subtracting to the angle inside, it will not affect the graph of this angle. So for this, if you'll see, we have to consider only graph for sin 2x. So what is a sin 2x graph? That is, period 2 pi by mod 2. That means pi. So therefore, period of cos x into sin x minus 2 pi by 3 is pi. So this is the way. So how to find period of two different functions when they are multiplying. So let's see one more question. So what is the question is? The question is, what is the period of the function? What is the period of the function? Period of the function. What is the period of the function? Sin power 4x plus cos power 4x. Sin power 4x plus cos power 4x. See here two different trigonometric functions having with powers. If these are having individual powers, directly we can say. So let's try to simplify this one. So what they're given is sine power 4x plus cos power 4x. So this we can write like sine square x plus cos square x whole square minus 2 sine square x cos square x. So according to what formula? A plus b whole square is equal to a square plus b square plus 2ab. So from here we will take a square plus b square as a plus b whole square minus 2ab. A plus b whole square minus 2ab. So this sine square x plus cos square x is 1. So 1 minus, here we will multiply and divide with 2. So we will get 1 by 2 into 4 sine square x cos square x. This we can write like 1 minus 1 by 2 into 2 sine x cos x whole square. So that is equal to 1 minus 1 by 2 into sine 2x whole square, or we can write 1 minus 1 by 2 into sine square 2x. So what is how can we take this one? So how can we take this one? So 1 minus 1 by 2 into sine square 2x, so we can write like 1 minus cos 4x by 2 formula. 1 minus cos 4x by 2 formula. So what we'll get is 1 minus 1 by 4 plus 1 by 4 cos 4x. So this will get 3 by 4 plus 1 by 4 cos 4x. So this will not affect our graph. So what will be the period of this one? So cos 4x period, if you'll find out, that is enough. So period of cos 4x is 2 pi by 4 mod 4. So 2 ones are 2 twos. So you'll get the pi by 2 as the period of this is sine power 4x plus cos power 4x. So this is the way. So how we will find out the period for the different kind of functions. So when we will solve the DPP daily practice problems, I will solve many questions based on each topic. So now extreme values of trigonometric functions. 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 Let's see what are the extreme values of trigonometric functions. So how can we find? First one, if the trigonometric function is in the form of a cos x plus b sin x plus c, if it is in the form of a cos x plus b sin x plus c, then the range or extreme values of this one will be c minus root a square plus b square comma c plus root a square plus b square. So these are the extreme values. So how can we find the range of this one in this way? So let's see the proof for this one. Let's see the proof for this one. So generally, let us assume this f of x is equal to a cos x plus b sin x plus c. So let a is equal to r cos theta, b is equal to r sin theta. So then we'll get a square plus b square. You will get r square cos square theta plus r square sin square theta. So which is r square is equal to a square plus b square, where r is root over a square plus b square. R is root over a square plus b square for r greater than 0. For r greater than 0. So if you'll see this cos theta, how it will become if I substitute the values in f of x. So f of x will become a means r cos theta into cos x plus r sin theta into sin x plus c. So this will become r is common. So it will become cos theta cos x plus sin theta sin x plus c. So which is r of cos theta minus x plus c. R of theta minus x plus c. So this is what f of x will get, right? So we know that clearly cos theta is always lies between -1 and 1 because its range also -1 to 1. So here we will start with the cos of r cos theta minus x. R cos theta minus x plus c lies between what. So r cos, generally this cos theta minus x, cos of theta minus x is lies between -1 and 1. So when we will multiply with r here, r cos theta minus x is lies between r and minus r. So when I'll add the plus c, it will be c minus r is less than or equal to r cos theta minus x plus c less than or equal to r plus c. So r value, what we got, root over a square plus b square less than or equal to r cos theta minus x plus c less than or equal to c plus root over a square plus b square. So this is our function f of x. So f of x will be lies between c minus root over a square plus b square, c plus root a square plus b square. So this is the way. So how we will get the extreme values of this one. Okay. So based on this topic, we will solve the problems in the next video. So please keep watching my video for good videos on Maths IIT, and please subscribe to my channel and support my channel to do the more videos. So thank you all. Please keep watching my channel.